and with a burnout effect. There's also the total ionizing dose. That means each event damages the ship a little bit, and if the total dose is reached, the ship will fail too. So currently we are working on the first prototype board. It is equipped with a Vertex 4 FX20 FPGA. It's a small one. It's not the final one. It's not space compatible. But it's enough for testing a few things. For example, we have an DDR RAM with 80-bit instead 64 or 75 too. That means we can test other error correction algorithms. For example, extend it to up to 3 bits of 64 that can be corrected. But there are limitations, so there's another algorithm that could correct to various bits of the 64. Or a third configuration that allows to compensate one chip failure, so that the 9 remaining chips will work like a standard ECC module. We have also a 5-channel NAND flash interface. They should work in the RAID 3 mode. That means we can also compensate a chip failure of 1. So, for testing external hardware like cameras or motors, we have an VHDCI connector from SCSI, but we're using it as GPIO for with 64 lines. And we have also 2 pin headers with 16 lines each that can be used for hardware. Also, there are 2 Ethernet fuse that was not easy to get them. We can use them for debugging or using the board as router. So, to not waste the possibilities, we connect the multi-gigabit transceiver to a few SATA ports. So let's have a look inside the FPGA. We have a PowerPC 405 core. It's a hard core, so it's real in silicon. We don't have to use the FPGA logic to build it. We have also 2 Ethernet emacs, so they are connected to the Ethernet fuse. When we have our DDR2 RAM, it's a multi-port memory controller. That is an IP core that is implemented with the FPGA logic. And it's connected to the PowerPC connector with 2 processor local buses. Then we have also a few more peripherals. For example, the block RAM that contains the bootloader, and UART that is connected to an S232 interface, an interrupt controller, an inter-EC controller for external sensors, for example current or temperature, or maybe the real-time clock. So that is all things that is provided by Xilinx. But now we have the components we have to develop ourselves. For example, the motor controller. So, the last part I want to talk about today is our concept for the antenna and the solar panel. A solar panel has a conflict with the antenna. They require the same space. They are both large objects compared to the other components on the rover. So our only solution is embed the antennas into the solar panel. Maybe a few people here have heard from slotted array antennas. Some people use them for wireless LAN. So it's possible to embed the slots into the solar cell to implement a high gain antenna. So, we have two antennas embedded. One is an X-band antenna for transmitting. It requires a high bandwidth, for example, to transmit the HD video, and a low bandwidth antenna for receiving the commands. The data rate is not more than a serial line. So, I would like to give back to Robert. Okay.
Okay, so let's see if Jack Crenshaw is angry at us because we're not answered his phone calls. Okay, now I'm going to call Jack Crenshaw. Just to give you a short introduction about him. Jack Crenshaw, you probably most know him because of he published really long list of articles in regards of embedded hardware development. He was on the Lunar Trajectory group back in 1960, working on the original, completely entire Apollo program, and he did the lunar trajectory calculations there. So that's one of the oldest geeks I know, absolutely. And he's pretty cool, and yeah, okay. So let's see if he talks to us. Okay. Yeah, it's quite a long list. Hello. First of all, he will tell something about himself and what he's done so far. And then he asked me to offer you to ask him 2 questions. Not more than 2 because we have a presentation afterwards and it would take too long. You could ask him 1,000 questions. I did, so believe me. Just think of something you want to ask someone who worked on the original Apollo program. I will just select one randomly and ask him this question, if it works. Oh, das sieht gut aus. Hello. Are you hearing me? Hello, Jack.
I've been having trouble getting online.
I see. Okay. Okay. Can you start your video?
Yeah, how do you do that?
No problem. I'm just starting my video, so you can see me first. It should be on any minute, yeah? Hello? And...
There you are.
Yeah, okay. And just at the bottom of the Skype window, you can see this blue button that we had yesterday. And you can click on it, and it shows Start My Video. So, okay, it looks like... Okay, and I should type... Hello. Okay. I will try to hold the laptop in regards of the audience, just to get a picture of them.
Yeah, I see you.
Hello.
Hello, man.
Okay. If you want, I can hold it this way. No problem.
Hi, guys. Okay, I'm sorry for all the problems. I couldn't seem to get online this morning.
No problem, no problem. Okay, now you're there and...
Okay?
Yeah.
Time to go?
Yeah, absolutely.
Okay. Hello. You going to introduce me?
I introduced you a little bit, but can introduce yourself if you want to, additionally.
Okay. Well, I'm Jack Crenshaw. Some of you may have read my column or my tutorial on compiler theory some time ago. I understand there's some interest in that. I'm a columnist for embedded